Now see here, next topic is that is eddy currents. So see here, if you take like this is the north pole of the magnet and this is the south pole of the magnet. Direction of magnetic field is like this, north to south, and a metallic plate is taken which is like this, and this metallic plate is oscillated between the poles of the magnet. When this metallic plate is oscillated between the poles of the magnet such that it intercepts the magnetic field lines. What happened here? In this case, magnetic flux linked with this metallic plate changes. As a result, EMF is induced and current is induced in this. But see here, whatever the electrons are in metallic piece or this in the bulk pieces of the metal, they are come into the motion and they start like moving in this way here. They appear that they have been caught up in the whirlpool or the eddies, and because of this electric current is induced current is set up in this. Because of this induced current, this metallic plate comes to rest after some time. According to Lenge's law, whenever the current is induced, that opposes the cause of its production. So here current is induced due to oscillation of the metallic plate between the poles, and so it starts slowing down its motion, and ultimately this metallic plate comes to rest. So this is called electromagnetic damping. So whenever the current is set up in bulk pieces of the metal due to change in magnetic flux, that is known as eddy currents. And now sometimes eddy currents are useful, and sometimes eddy currents are not useful. So somewhere if you want to reduce the effect of electric eddy currents, induced eddy currents, what happens in the metallic piece like this, the slots are made, and when the slots are made on the metallic pieces because of this rectangular slots, because of that area reduces, as a result the value of the current reduces, and when the value of the current reduces, the effect of eddy current gets reduced. And also what happen here, these metallic plates are laminated, and these when they are laminated and the planes of the laminated plates are parallel to the magnetic field, then also the effect of current or the eddy current gets reduced. And the eddy currents are useful in case of the electromagnetic damping. One we have seen a moving coil galvanometer. In moving coil galvanometer also we have seen there is a north and south pole of the magnet over here, and in this case a coil is placed here, metallic piece, soft iron, and the coil is wound over this. So when this coil rotates here, the eddy current gets induced on this metallic coil, or that is a soft iron, that helps in bringing the needle in equilibrium. That is also an example of electromagnetic damping. And also eddy currents are very useful in the magnetic brakes in trains, and also induction furnaces here. So these are some examples where eddy currents are important. And see here, like in case of the transformer, because of the eddy currents heat is produced and energy is lost. So in that case eddy currents are not important. So because of eddy currents, if heat is produced and that is actually creating loss of energy, so that is a part where eddy currents are not useful. So the eddy currents are similar to actually the currents, but these currents are set up in the bulk pieces of the metal.